Hello everyone, welcome to your next class. In this one, we're going to take our massaged information from our previous section where we took some text from our sample data in scikit-learn. 4 categories specifically. We quantified them, so we counted all the different words that are in each of the documents and topic types. We did our TF, IDF, our term frequency independent documents frequency calculation. Take all that information and we're going to pass it into our naive Bayes classifier model and see if we can predict some new predict classes from new pieces of text. So in this class, we're going to learn how to build that naive Bayes classifier using scikit-learn. We're going to take our natural language processing techniques that we learned from our previous class and pass them into our classifier, and then see if our trained model is any good at predicting new classes from new pieces of text. So we can take some test data that we've reserved from our library, or we can actually just give it some new text that we can write on the fly to see if it's any good at analyzing that as well. So this is all an area called natural language processing. This is taking text information and applying machine learning techniques to it to see if we can get a computer or a machine to understand features of text or understand what a person is writing about. We can do all different types of stuff, from determining what the topic is, to, like, is it spam or not, or is it about science, is it about astrology, astronomy. We can also use it to determine sentiment, for instance, sentiment analysis, another area of natural language processing. But for now, we're going to build our naive Bayes classifier around all of this massaging that we did in our previous class. So with that, let's go into the code for that and see how this is all working. So the first few rows of code are going to be very, very similar to the code that you saw last class. There's a new import that's going on here. I'm importing the multinomial naive Bayes classifier model from scikit-learn. This is just the specific one that I'm using because it's a little bit more accurate and advanced. It can handle many different types of parameters as opposed to just a few. We have our data set here, which is fetch 20 news groups. These are emails that are being passed around universities or news articles. We have our count vectorizer and our TF-IDF transformer from our previous class, and we have imported NumPy here just in case for some calculations if we need them. Remember, the first thing we did was load up our count vectorizer, and we've model, and we've loaded up our data, which is what we had before, our categories and our data for training. All right. We then did a count of all of the text that exists for our training data, counting each word as it exists in every document, and converted all of those counts into our TF-IDF score, and then calculated the probability that that word was going to occur in that document. And remember, then we transformed all that information into a form that we can then read. So what we then had from this was X train TF-IDF. There we go. I'm going to just block that out. So what we have here is, okay, so in document 1, word 20283, there's a 6% likelihood that that word was going to occur in that document, or that document type, essentially. Okay, so this is all from our last class so far. The next thing we're going to do is create our naive Bayes multinomial model. I'm going to keep all of the parameters as default for now, so we're just building our model object, and then we're passing in our percentages. So, okay, we're saying, we're passing in all this data here, essentially. We're saying, okay, for every row of data, it's, document 0, and this word occurred, and there was a 6% likelihood of that word occurring. And oh, by the way, the target, the topic for that word was, electronics or something. We then fit all of this data into our naive Bayes classifier. This is literally what we're doing is now, if you remember our formula from the past, the probability of event A given some data D and the prior likelihood of A and D. Now, all of that stuff that's basically what's being passed through here, and it's being constantly updated. Each time we are running that calculation and then updating our prior information over and over and over again, okay? So once we have created this, once we fit this data, we can then pass in some test data to see if it's accurate, or we can even just pass in new documents to see if it's able to actually predict the topic if we know what it is going into it. So we've trained our model. I have then created a list, which is a set of new documents. It's just really just 3 words for each item in this list. So I'm trying to say medicine is neat and Pluto is a really cool planet because we have 2 different topics, or we have 4 total topics, and I want to see if we can get it to correctly classify the first one as being about medicine and the second one as being about space. It might not actually be able to do that depending on the information that it learned from our naive Bayes classifier. So the first thing I do with that information is I then create a new count vectorizer. So I count these words as new words, and then do a, I predict from this. So we need to also, we're also missing a line of code here, I think. Oh, no, actually, everything is fine. We have our new TF-IDF. Yep, this all should work just fine. Okay, let's try this out. Next line we have here, it's going to print everything. So let's just run this and see what happens, okay? So first off, we've created a prediction from our new TF-IDF score. We have created our prediction from that. We have our new counts here, and then what we do is a for loop where we have put all this information together and say, okay, we've given it these documents, see if it classifies it properly. Our for loop here, so it says, okay, this piece of text, it labeled it as medicine, and this piece of text, it labeled it as like cryptography. So our first one was able to, our first new piece of text was able to be, both of these actually were not classified properly. The first one was classified as medicine, and the second one was classified as space. So this means a few things. First, maybe our documents don't have enough information, as in they have, they're only 3 words, so it's really hard to figure out. It doesn't know that sci.med means medicine, so maybe in these documents, medicine isn't, the word medicine isn't used that often, so it's mixing it up with something else. Actually, it did actually classify that one properly. Sorry, silly me. So the first one it did analyze properly, so medicine definitely has medicine in it, but like maybe Pluto and planet aren't very common in our space emails, because those emails are, passed between professors at universities, and they don't talk about Pluto being a planet, or talk about Pluto that much at all, or something to that effect. So it's important to understand that sometimes classification mislabeling, or when things aren't analyzed properly or predicted properly, it can be both because of the data that you pass in for training or the data that is trying to learn from. Maybe this is just not enough information for it to do accurate assessment. So what we'd want to do to see if our naive Bayes classifier was doing a very good job was maybe have it predict based on a test subset. So we could build this line of code to then do an accuracy assessment. We're not going to do that in this section. Maybe that is something that's going to be used in your problem and answer section for this chapter. But for now, basically that's how a naive Bayes classifier is going to be built. We've massaged our data, we've taken our text, we have vectorized it, we've turned it into numbers that we can then pass in to a naive Bayes classifier. It makes it very easy for our model to say, okay, the prior likelihood of this item as opposed to this item, and then do some posterior probability calculations. So with that, guys, let's just do a recap. The thing that we're missing in this data science workflow here is that we didn't do accuracy assessment, but we've done that in previous sections, and maybe we'll do it a little bit more concretely in following sections, okay? So what did we learn from this class? We learned how to create a naive Bayes classifier that can predict the class of a new piece of text. So we have we trained our naive Bayes classifier on training data, and then gave it some new data, some new pieces of text to see if it was able to accurately assess that. And it was able to assess one of our examples and accurately and not the other one. So there are many different things that we can do. We can talk about parameter tuning, which would improve the accuracy of our model. We spent a little bit of time on that in our last chapter. You can do that with all models that we talk about henceforth. But I want to spend more time showing you how to build these things so you can then learn how to tweak each of these parameters by yourself as you go, and learn how all of these things are working once we give you the basics of them. So with that, guys, thank you very much, and I'll see you next class.